Hi, I'm Caleb from Group 8, and I'm here to show you one of the most revolutionary concepts known to physics since the 17th century. Hooke's law was discovered by Robert Hooke, a 17th century physicist. Hooke's law is a principle of physics which states that the force F needed to extend or compress a spring by some distance x is proportional to that distance.
So what is Hooke's law? Hooke's law is represented by F equals negative kx, where F is the force in newtons, and it's also considered the restoring force. Negative k represents the spring constant, and x is the amount of extension of the spring, which is commonly measured in meters.
In order to perform this experiment, a few things are required. You're going to need a few different springs, preferably each with a different spring constant, weights in consistent increments. In this case, we have 10-gram weights, a ruler, preferably metric, to measure the displacement of the spring, some kind of metal frame to mount the ruler and spring onto, a hook to attach the spring with, a mass hanger to put on the bottom end of the spring to hang mass off of, a wire or pointer so that you can use it as a marker to measure your displacement, and some kind of base to stabilize the whole assembly.
Okay, so once you have your experiment set up here, make sure the needle is zeroed out up here to get the most accurate results. The experiment is performed by adding weight in 10-gram increments to the spring and then measuring the displacement.
The data here shows the multiple trials attempted during the experiment and the linear representation between the mass in grams to the displacement in centimeters. This data here shows the differences between spring 1, spring 2, and spring 3 and their average spring constant. As you can see, spring 1 had a spring constant of 20, spring 2 had a spring constant of 10, and spring 3 had a spring constant of about 2. The lower the spring constant, the higher the displacement when weight is added to the spring.
In order to calculate the spring constant of each spring used in this experiment, we need to use an equation for gravitational force. Gravitational force is represented by F equals mg, where F is force, m is the mass, and g is the acceleration due to gravity. Since we've already shown that force is equal to negative kx, we can then set mg and kx equal to each other and solve for the spring constant k.
A few examples of modern-day uses of this principle consist of automotive suspension systems, pendulum clocks, hand shears, wind-up toys, rat traps, and of course, a slinky.
Shock absorbers are rigid springs attached to each wheel of a vehicle. Compressive forces in the spring counteract the vertical up and down movements of the vehicle, enabling a smooth journey in your car. The spring should be strong enough to sustain the weight, preventing the suspension to reach its limits on all situations, including weight transfers.